we're going to look at air pressure. So we have some definitions here that we are going to get into your notebook by another screen. But we're looking at air pressure, elevation, and altitude. And what is gravity, what's air pressure and density, air pressure and elevation, air pressure and temperature, and how to measure air pressure. So have you been swimming? So this is kind of a view of air pressure or pressure in general. So the pressure that you're feeling at the bottom of the pool is a lot more than you feel at the top of the pool, and we're going to talk about why that is. So air pressure, the result of the weight of a column of air pushing down on an area. So weight relies on gravity. You weigh less on the moon. Not that your mass is less, but that you weigh less, and that's because there's less air pressure. So air pressure, again, is being felt because there's air pushing down on you. So air pressure and gravity. At a high altitude, there's less air pressure because the air is less dense. At a low altitude, there is greater air pressure because, again, the air molecules are so compact and so dense. Things that make up our atmosphere: nitrogen, oxygen, and carbon dioxide. So gravity pulls air molecules down, creating air pressure. The air pressure at the top of a mountain or at a high altitude has less air pressure, and the air pressure at sea level is greater. And that's, again, because at sea level, the air molecules are more compact together. They have a greater density. They are compact, they're pressed together, so there's more air pressure. Whereas at a higher altitude, the air molecules themselves can be more spread out. So it has less air pressure or a lower density. This is kind of a funny memes here, but basically you have a sea level dweller. That's a person who has spent most of their lives at sea level. Therefore, they're used to a lot of air pressure, whereas a mountain man, he's used to less air pressure, right? Because, again, at a higher altitude, there's less air pressure. So let's talk about how that compares to the amount of oxygen. So there's still 21% oxygen at both of those. It's just how far those oxygen molecules are apart, right? So here at sea level, or closer to sea level, there's going to be more oxygen molecules per square inch, whereas higher up, there's still going to be the same number of oxygen molecules. It's just they're going to be a lot further spread apart. And then we've got the blobfish. And now we're looking at pressure. And so the look of the blobfish is usually found at the very bottom of the ocean, and it experiences constant high pressure because not only is it at sea level, but it's a lot lower than sea level. So we've been talking about sea level versus the top of a mountain. Now we're looking at even further below sea level. And so it's constantly under pressure. Applies to what you've already learned as far as layers of atmosphere. The exosphere, which is the one farthest from Earth, has the lowest amount of pressure because, again, the air molecules are not as compact together. They have more room to spread out. Whereas the troposphere, being the one where we live, where weather happens, it has the highest amount of pressure because there's more gravity pulling down on those air molecules and they're more compact together. Temperature, warm air is less dense and has lower air pressure, and cool air is more dense and has higher air pressure. We'll revisit this a little later. The coldest layer, troposphere being the densest.